Hello, AP Physics 1. This is Giancoli Chapter 4, number 51. This one goes out to Ben. Thanks for asking this question, and my apologies that I couldn't get to the answer soon enough. So here's the actual question. A child slides down a slide with a 28% incline, and at the bottom her speed, that sucks because that means velocity, not acceleration, is precisely half of what it would be if the slide had been frictionless. Calculate the coefficient of kinetic friction between the slide and the child. So right now it feels like we don't have enough information, right? Because number one, it wants velocity, which sucks because we know that all of our free body diagrams so far have been dealing with Newton's second law, and that's with acceleration. So we know we got to do a little bit of like kinematics math to go from acceleration to velocity or some kind of math there. So well, the first thing we should do is just gather our information, right? So it looks like we have two situations, frictionless and a situation with friction. And even though it feels pretty kind of not hopeless, but just not enough info, maybe some things will clarify itself after we go through our typical procedures, namely drawing a free body diagram, right? This is a girl. And then with friction, right? So we know that this is 28 degrees, right? This is 28 degrees. We know that this will just be the component of gravity, which is mg sine theta, and we know theta is 28 degrees. So we have a number there. That's good. And this is 0. Haha, nothing here, frictionless, right? And I mean, I guess we could do the normal force, but it really doesn't matter, normal force. With friction, this is a little bit different. This is going to be, again, mg sine theta. Normal force we know is mg cosine theta. That means this thing here is the friction coefficient, mg cosine theta, right? Very typical for incline problems. And we know that for this one, the frictionless one, we're just going to set this to be MA. Why not? Right? This is the sum of forces. Oops, that looks ugly. Let's just set up the sum of forces to be equal to MA. And that kind of sucks because the problem is about velocity. And then here, we need to make the sum of forces is equal to M. And it can't be the same old A, right? It's got to be a different acceleration if the velocity is going to be halved at the end. So how do we find that different acceleration? Well, let's do the old VVATX, VVATX. We know that initial velocity is v1. Oh, no, initial velocity is 0. Final velocity is vf. A, we know, let's just call this sucker A. And then let's choose between time and distance. You know, I'm not going to choose time because in these two different situations, because they're going at different speeds, the time is going to change. But the distance that this girl travels is going to stay the same, right? It's the same slide. So let's go with x. Seeing this, I think one equation should stand out, and that's going to be the vf squared is equal to v initial plus 2ax equation. And this is 0. So let's solve for a. If we solve for a is basically equal to vf squared over 2x. I'm just going to make x equal to 1 so that it goes away. Get out of here, x. So just vf squared over 2. Okay, that's kind of somewhere. Kinda. Let's try it over here. VVATX, what do we know? We know that V initial is 0 again. We know that VF, the final V with the friction, is 1/2 of what it was here, right? So this is V friction. I don't know. Let's just keep the two sides, and we don't need to do any sort of fancy letters. It just kind of gets ugly. This was 1/2 of the of that final velocity over here. A is something that we'll want to solve for now, and t is gone, and x is still 1. So let's solve for this. So this is 1/2 VF squared is equal to, oh, right, let's just write the A here, is equal to the new A, which is still V initial plus 2AX. If we kind of do the math here, this is VF squared over 4. If you don't know how I did that, 1/2 squared is a quarter, is equal to 2AX. That means A over here is equal to VF squared over 8x. X is gone. Okay, so this is actually not a bad place to set up. Look here. This is basically VF squared over 2. This is VF squared over 8. So I could actually make a ratio here. Let's make A, the frictionless one, actually A. Hooray, hurrah. And this is equal to a quarter of this A. Okay, so maybe I got to do a thing. So this is the no friction, so I'm going to call it no friction. AN is equal to AN, right? But this A with friction is equal to a quarter. Why did I write a half? A quarter of the acceleration with no friction. Does that clean things up, right? So it's basically, man, that looks ugly. This is a quarter of the acceleration with no friction. Okay. This is a great place to be, because now I just need to do a sum of forces, and as long as I know this, a lot of things will sort itself out. Okay, let's do some sum of forces stuff. Here, let's go without friction, frictionless. We know that the sum of forces is equal to mg sine theta, which is equal to ma, and this is a without the n as in no friction. And if we could cancel out these this m, so g sine theta is equal to the acceleration with no friction. All I got to do is plug in. The acceleration with no friction is basically 4.6 meters per second squared. How did I get that? Well, g is 9.8 meters per second squared, and theta was 28, right? So that's pretty good. With friction, sum of forces is equal to the component of gravity down, mg sine theta, minus the friction, which is the friction coefficient, mg cosine theta is equal to m. And look, I'm gonna write 1/4. What do I keep writing for? I mean, why do I keep writing to 1/4 a, right? Because if you remember, a with friction is equal to 1/4 of the acceleration without friction, right? So here we go. Let's start solving. That means that negative with the coefficient mg cosine theta is equal to m1/4 an minus mg sine theta. Oh, we could cancel out all these m's. Why didn't I do that earlier? Then negative, no, let's make that into a positive. Cosine theta is equal to g sine theta minus 1/4 an divided by cosine theta, divide both sides by cosine theta. So friction coefficient is equal to g sine theta, it's a theta, minus 1/4 of that initial acceleration, which we have right here, haha, right, divided by g, oops, forgot the g there, g cosine theta. Okay, if you plug in all your numbers, you should get that the friction coefficient is like 0.398 or so. If you round it to 2 sig figs, which is what the problem gives you, you get 0.40. Okay, so a lot of stuff happened in this. Probably the hardest part was trying to find that acceleration, just because it's kind of a mental shift from what we've been doing. And I know the problem like didn't have a lot of information, but just because I did my free body diagram and I did some sum of forces and I did some random equations, we were able to get enough out of it to get the answer. And again, what I did was I found the acceleration in terms of the relationship between the two accelerations. And then I did a free body diagram. I did sum of forces, and then I solved. I know that sounds pretty easy. Thanks a lot for watching this really long video.